Okay, so yesterday we did the basics. Yesterday we kind of did a day of, hey, remember this? Hey, remember that? Kind of thing. So what I'm going to do today is the first problem I'm going to actually work out for you. So this is the first one on your practice problems. Okay, here's the first one. So we need to graph x squared plus 4x plus 3. So it's going to be the shape of a parabola. But we're going to take only everything from the right of -2. Everything greater than -2. Basically, the positive part of the parabola. Right? And we're going to reflect it. What type of shape is it going to be? When I reflect, see it's already drawn for you. When I reflect that over y equals x, what type of shape is it going to be? This is half of a quadratic right now. No. What's the inverse of a parabola? A square root function. It's going to be a square root function. All right. So now that I've said that, I'll go ahead and get rid of this. All right. If I hadn't had it already graphed for me, I would probably want to factor that. That would be my first guess, right? Is it factorable? Is it factorable? Looks like it's factorable. So I went over 3 and over 1, and then we went over 1 up 1, and we went over, right? We graphed it. If I didn't remember that trick that we did yesterday, where if it's 1 away, we're just going to square 1 and it's 1 down. If it's 2 away, then the vertex would be 4 down. If it's 3 away from the axis of symmetry, the vertex would be 9 down, right? If you didn't remember that, the other way to remember how to find the vertex is to locate the axis of symmetry. The axis of symmetry is going to give me the x part of my vertex. So if my vertex is -1, the way I find the y is by using the equation y equals whatever x is, -1 squared plus 4 times -1 plus 3. 1 squared is 1, minus 4 is it minus 4? Yeah. Minus 4 plus 1 is -3. -3 plus 3 is +3. I did something wrong. You guys help me out. Let's put it in here. It's easier. Where did I go wrong? -1 plus 3. Let's do it this way. -1 plus 1. It's still giving me 0. What did I do wrong? The vertex is -2. Thank you, Taylor. Do you guys see how I knew I was wrong because I kept getting the wrong vertex? -1 is 0. That's why, right there. It's -2. Now it'll work. So glad I was recording that. See, it's okay to make mistakes because you learn from them. Okay. So x is -2 plus 3 and -2 plus 1. So -2 plus 3 is 1. And -2 plus 1 is -1. So my y is -1. -2, -1. Again. All right, so that's how we could have come up with the graph. Fortunately, it's already graphed for us, and it told us everything to the right of -2, which is all the positive part. So I'm going to go ahead and erase that. Now I have to find the inverse. I can find the inverse graphically. I think I'll do the inverse in red. I can find the inverse graphically by just transposing the points. So if -2, -1 is one of my points, then -1, -2 is going to be, I should write it down. So this is my inverse function. And in blue, it was -2, -1. So the inverse is going to be -1, -2. They're going to be switched. This is the easiest part. So -1, -2 is right there. Once I have the vertex, I can graph it, because I know that a square root function has the same magic numbers as a square function, only switched. So instead of going, so we're going to go over 1, and the square root of 1 is 1. What's my next magic number? What's my next square? Normally it's over 2 up 4, so I'm going to do over 4 up 2. So 1, 2, 3, 4 up 2. And then 9 and 3, exactly. So here is the inverse. Or I could have just taken that one right there, which is -1, 0. -1, 0, and now it's going to be 0, -1, which is one of the points I found. Okay, that being said, the next thing you need to do is you need to do that, we need to find the inverse algebraically. So algebraically, in order to find this algebraically, we're going to switch x and y. So this is technically a y, so I'm going to switch it to x. X equals y squared plus 4y plus 3. I need to solve for y. I showed you yesterday that a way to solve for y is I have a y squared, and how do I get rid of a square? Square rooting. I can't square root until I have a perfect square. This is not a perfect square. So I need to move that 3 over to the other side. So now I have x minus 3 equals y squared plus 4y. What do I need to add to make this a perfect square? Take 4, split it in half, and square it. Okay? All right, now we have plus 4 minus 3 is plus 1. So x plus 1 equals y plus 2 squared. Now can I get rid of the square? Thank you. So I'm going to get rid of the square by square rooting both sides. And now I have the square root of x plus 1 equals y plus 2. So my inverse function is square root of x plus 1 and subtract 2, which is over to the left 1 and down 2, so it matches. So doing the algebra piece basically tells you whether you're right or wrong, right? Okay. Do we all need to stand up? Yes. You could have just taken the points, but you have to be able to do it algebraically in order to get full credit on your test.
Okay, but you can check your work.
You can check your work that way. This is the easiest one. Okay? I'm moving on. All right. This table all needs to wake up right here. Everybody sit up. Okay. This one's easier because look at it's already a perfect square. Right? Because half of 6 is 3 and 3 squared is 9, so this one's a perfect square. Remember that because that's number 3 on your practice. Okay, this is where I'm going next. Okay? Is 1/2 equal to 4/8? What if I took the inverse? But if I take the inverse of 1/2, then what's the inverse of 8/4? Is it still true? So as long as I take the inverse of one side, I could have to take the inverse of the other side and it's still equal. That's another strategy you can use. Okay. Just imagine what this is going to look like if I reflect it over y equals x. If I reflect this branch over this line, what do you think it's going to look like? It's going to look pretty close, right? So this one is g of x, g of x. So I could just transpose the points right now, correct? So this one is -2, +1. So 1, -2. That's one branch. And this one is -1, 2, 3, 4. -1. So -1, -4. 2, 3, 4. So if those are my two dots, isn't my... Wouldn't this be my asymptotes? Like that? And so then this would look like this? If you're not comfortable doing that, then just wait and do the problem and then graph it. Alright, so in order to, this one is in this form. Y equals, there's a 1 out in front. Remember how to graph these? So I'm going to the left 3, I'm not going up or down, and I have a stretch of 1. So we went over to the left 3, that's how this was graphed, and that was my, those are my asymptotes, and over 1, up 1. Okay? All right. So now, to find the inverse function, I need to find the inverse function, I need to switch x and y. Ready for that? Yes, Mrs. Mona, we're still ready. Okay, so wherever I see a y, I'm going to put an x. So x equals, I don't need all this stuff, right? Just this. So x equals 1 over y plus 3. I'm trying to solve for y. Do I want y in the denominator to be able to solve it? I want it on the left side, but the first thing I need to do is get it in the numerator. So can't I do that strategy I just talked about? Instead of being x over 1, it's going to be 1 over x. And instead of being 1 over y plus 3, it's going to be y plus 3 over 1. But I don't really need the 1, right? So it's just y plus 3. Now how do I solve for y? And so we're done. 1 over x minus 3 equals y. So this is no shift on the x-axis and a shift down 3. This is no shift on the x-axis and down 3. Exactly what I have. But was this really that hard? It looked hard, right? But it really wasn't that difficult. Okay, so are we ready for... See, I messed up. I wanted all of that. Make it green now. And the last thing I need to do is, what did I forget? My label. You need a label. All right. We ready for the last one? Okay. Scared. All right. So this one's different because what's going on once I transpose x and y here? There's a y in the numerator and the denominator. Yeah, it's going to work. Okay, this is why I told you can't throw things at me, okay? All right, we ready? Okay, so taking the inverse of both sides is not going to help me out at all because I'm still going to have a y in the numerator and a y in the denominator. Okay, so in this case, I just want to get rid of the denominator at this point. So how I'm going to do that is I'm going to multiply both sides by y plus 6. What do you think the most common error is on this one? They just cancel them. That's the most common error. Okay. Alright, so that makes this go away, and I'm left with x times y plus 6 equals y, or xy plus 6x equals y. But I still need to solve for y, and I've got a y on this side and a y on this side. I need all the y's on one side and all the x's on the other side. So I'm going to move that y over here. Now I have nothing on that side. I have an x and a y. There's nothing I can do about that right now. I have a negative y, and I have a 6x. 6x has nothing to do with y, so we should stick that on the other side. Get rid of it. So now I have x times y minus y equals 6x. Negative 6x. Thank you. Now I can pull a y out, right? I have to tell you that this was the one thing I struggled with the most when I was in 8th grade. We did this in 8th grade. Why is it x minus 1? Because y times x is xy, and y times negative 1 is negative y. Okay? Now, I can divide by x minus 1. And now I have solved for y. Okay? But, can you graph that? Are you ready for the last part?
Yeah.
We're not done. I told you! I warned you! Do you see why I gave you the college talk before we started? Okay. So, I can't graph that because it's not a rational function because it's not in this form. Right? So what do I need to do to get it in that form? But then I'd still have an x in the numerator. What did I tell you was never going away?
It follows you everywhere.
Long division. It's not going anywhere. I told you it wasn't. I told you it was never going away. X goes into negative 6x, negative 6 times. Negative 6 times negative 1 is, guys, way too much talking. Negative 6 times x is negative 6x. Draw the line, change the sign. I'm left with negative 6. This is my remainder. My remainder out of x minus 1 minus 6. It's just challenging. It's just a lot, right? And one problem? Okay, here's the deal. I'm not going to put one like this on the test. Not this hard. This is a lot, right? I don't want to even start grading something like this. But there will be one for sure on your practice assessment, or your assessment of practice, your homework quiz.
Wait, what is this looking at just right on the side?
That's not a bad idea, but, so that tells me you practiced it, so I'm going to grade the practice, so you guys get to practice it together right now, right? So I'll grade the practice, but I won't grade it as a test question, okay? It is free game on the group quiz, though, okay? I just won't individually assess this one. on a test. Okay, so I'm going to go ahead and pass out your practice because this is as hard as it gets, okay? It's really not hard, it's just a lot. It's all the stuff you've already done before. We're just putting it all together, which makes it very tedious. Okay, so I'm going to pause it. Okay, so I have a request to do number 2, or at least get it started. Can somebody tell me what the function is? G of x, 1, hold on guys, I can't hear when I've got more than one person talking to me. So G of x.
Plus 2x, comma, x is greater than the line. Negative 1.
Okay.
The little line under the...
Got it. Okay. So, we looked at one of these yesterday, correct? We could factor it. We could do a GCF. You could complete the square. Just factor it. Okay. So it's x squared. GCF's the easiest way to do it. So x and 2 and 0. Is that right? Right? So my zeros are negative 2 and 0. So what's my axis of symmetry? So what's my vertex? Negative 1, negative 1. Right? And then to graph the rest of it, I would go over 2, up 1, 2, 3, 4. Over 2, up 4. So here's my graph. But x greater than or equal to negative 1 tells me I need to erase anything that's to the left of negative 1. So there's my graph. So G of x. Yeah.
Is it always 1, 1, and like 4?
Yep.
And then like 3, 9?
Yep.
Do we have to do 3, 9?
You don't have to go to 3, 9. So are we good? That's the first part. So what's the second part now? Now I have to switch x and y. So I'm going to switch that to an x and this to a y. X equals y squared plus 2y, right? Now you got to make it a perfect square and then square root it, okay? You're going to add 1 to both sides. 2 divided by 2 is 1, and 1 squared is 1. So I would add 1 to both sides, and I would get x plus 1 equals y plus 1 squared. You guys can finish it off from there. So now I have x equals, square root both sides, and I get square root x plus 1 equals y plus 1. So my graph is going to be y equals square root of x plus 1 minus 1. So I'm going to go to the left one and down 1. Left 1, down 1. There's my vertex. Square root function is the same magic numbers, right? 1, 1. And what's my next magic number? Instead of 2, 4, it's going to be 4, 2. Instead of 2, 4, it's 4, 2. 1, 2, 3, 4, up 2. Now, can you guys see that? Does that make sense? If I were to take and put the y equals x, Does it make sense?
When she finished,
Isn't it completely? No,
yeah.
right? Because then it would make it not a function. Are we good? Okay.